Hello, and thank you for joining me virtually for this presentation. I'm Josh Senecal, Administrative Group Leader of the NIF Information Technology Group. I work with Ramesh Vadlamani, who is the NIF IT Mid-Tier Leader. This is a report on progress on a proof of concept to move NIF Optics Inspection from a dedicated virtual machine cluster to containers and Amazon Web Services. The National Ignition Facility is the world's most energetic operational laser facility. Its electrical system is capable of putting out a peak of 1 trillion watts over 400 microseconds, and the facility can generate a peak of about 1.8 megajoules of ultraviolet laser energy. This energy is used to compress fusion targets to a pressure of 100 billion atmospheres, and at their hottest, the targets are 6 times hotter than the sun's core. We have about 7,000 large optics that are inspected regularly. Frequent exposure to such laser intensity can damage the optics. Automated inspection analysis allows us to more efficiently repair and reuse the optics. NIF Optics Inspection is a set of software that processes and analyzes images of the NIF's optics. We have about 7,000 large optics that are inspected regularly. These inspections are done using a variety of cameras, some of which are on beamline, meaning they image optics that are actually installed in the National Ignition Facility, and some are off beamline, meaning they are in a separate laboratory and image optics that have been removed from the facility. In all cases, the images and associated metadata are written to the file system, where OI picks it up and uses code written in Perl, MATLAB, and Java to analyze the image, looking for damage and other flaws on the optic surface. We write these results to a database, and they're used to make decisions as to the health of the optic, if the optic should be refurbished, if it should be permanently removed from service, and so forth. This information is also used to visualize data about the optic and track these defects through time, seeing how they've changed in size. To not negatively impact shot operations, OI must deliver analysis results in a timely manner. To handle situations when we have a data surge, OI uses a compute cluster to process jobs in parallel. For more than a decade, this cluster has provided reliable service. Each node in the cluster is a virtual machine running Oracle Enterprise Linux on NIF's own server hardware. Job scheduling is handled by Slurm, which is a resource manager originally developed here at LLNL. Although this is a cluster of VMs, they may as well be bare metal because they still require a lot of maintenance. And this is a direct quote from the IT team. Things like OS patches, Slurm configuration changes, application or library installs, volume mounts, etc. need to be applied across all nodes in the cluster. And each node still needs to be monitored for security and other things. Further, each VM node consumes a significant amount of resources even when it's idle, making those resources unavailable to other processes and VMs. The other issue is the actual node utilization of the cluster is low. This is a combined graph covering a period of almost 2.5 years. The blue bars show the number of jobs processed by each node. The red line shows the percentage of time during that 2.5-year period the node actually spent processing. For example, Node 3 processed almost 15,000 jobs, but it spent a total of only 48 days actually processing data, for a utilization of only about 5.2%. Node 37, with the huge blue spike in the graph here, was busy for about 13 days, for a utilization of about 1.4%. In fact, no node in the cluster exceeded 7% utilization. So you can see that the effort required to maintain these nodes is rather disproportionate to the amount of time they're actually processing data. Ramesh and I are working on a proof of concept to containerize OI, but what's a container? I didn't really know what containers were until I started working on this project. In brief, a container is a packaged set of local directories containing an application and what it needs to run. It allows you to move your application and its execution environment together, removing any dependencies to the underlying operating system. The container runs as a separate process on the host operating system, and it's possible to have more than one instance of the container running on a single machine or running across multiple machines. Docker is probably the best known platform for container creation and manipulation, and that's what we're leveraging in our project. The OI container image is built on Oracle Enterprise Linux 7, which is a Red Hat variant. On top of that, we install the various Perl, MATLAB, and Oracle Java and database libraries and binaries we need to run. On top of that, we install the OI codebase itself. The container runs on a host operating system on hardware that can be on-premises or in the cloud. The container currently totals about 6 gigabytes in size because some of the modules, particularly the MATLAB runtime, are very large. For the case where we're on premises, we're looking to move shared libraries outside the container to make the container smaller and improve efficiency. We anticipate some significant benefits from placing OI into a container, and this POC will allow us to evaluate to what extent we might realize those benefits. First, we anticipate there will be significantly reduced IT effort. The same software runs on each node in the VM cluster, so one container image will meet all our needs. IT won't need to maintain the VM cluster anymore, and instead can provision some significantly fewer machines for executing the containers. We anticipate there could be improved reliability and availability. The container can run anywhere. This allows us to run on NIF's own hardware or LC hardware. If necessary, we can run in the cloud. We could even provision a cluster of people's desktop machines to process OI data in an emergency. We anticipate there may be a reduction in costs and want to understand the potential. By eliminating the VM cluster and only spinning up containers as needed, we should require a lot less physical hardware, and that hardware could be put to other productive uses or eliminated. And what is the cost savings if we just push it all out in the cloud and let Amazon deal with it? Currently, we have a proof of concept container that runs on premises and processes OI data successfully. When needed, we can then take steps to implement a solution to eliminate the VM cluster. We're currently in the final stages of getting our container running in Amazon Web Services. Working with our partners at Amazon, we've resolved issues getting the container to spin up in the LLNL Virtual Private Cloud. We're currently iterating on debugging our code to get it compatible with AWS, properly dequeuing messages when jobs arrive, retrieving files from input buckets, and the like. Once these issues are resolved, we'll begin processing OI data to obtain information about possible cost savings. Thank you for joining me for this presentation. Please contact Ramesh or myself if you have any questions or would like to discuss anything with us.